joined by Goodness. I'm probably going to mess up your last name, Goodness, so I apologize. But Goodness Okpani, and I should know how to pronounce that, but I don't. So welcome to our API security track, and I know that you're going to be talking about approaching protection at a code level. I'm really excited to hear this talk as well.
Yeah. Hi, everyone. My name is Goodness. I'm from the Chief Technology Officer for Ethnos IT Solutions, all the way from Nigeria. I'm so happy to be with you guys. Um, let me just start by talking a little about API usage over the years. I mean, we're talking about APIs. It really is not new technology. It has always existed. I mean, if you go back history, you would see that APIs have always existed as far back as 1960. Would you believe that? All the way. And of course, between 1960 to 1980, you had, very little implementations of API, I mean, simple programmatic exchanges of information. And then, of course, you go to 1980, between 1980 to 1990, and then you begin to see more specific implementations of API using object brokers, procedure calls, program calls. And then you move to 1990 to 2000, you begin to see more and more sophisticated way of implementing APIs, way of exchanging information between new platforms. But then between 2000 and today, there has been this exponential growth in the use of APIs. And that's exactly what Postman even recorded in the graph. You would notice that just between 2015 and 2021, they had just been almost 1,000.9 million API requests. So if you compare the number of requests between just 2015 and 2021, you would notice that it is more than triple or even four times the number of requests all the way from 1960 up to 2000. And again, what has contributed to this? Well, the reason is not far-fetched. I mean, one very fine reason is the fact that recent times developers have begun to move away from the monolithic way of designing applications to a way of developing applications using microservices. So you begin to decompartmentalize applications into chunks, and you have different chunks of that same application but broken down into microservices. So, and that's the reason why you have more and more people speak about APIs, more and more people speak about this. Now, you see, the thing about the increase in the use of APIs is because it has now warranted the need for more and more security conversations regarding protection of API security protection. Now, again, what are some of the ways that the typical traditional, what I would call the traditional approaches to protecting APIs? Well, of course, one of the things that have been put in place is what you have as your API gateway, simply a way of implementing or managing scalability of APIs, especially with regard to authentication and authorization. So of course, that's one way, traditional approach of protecting APIs. Another way which vendors have put in place, again, is with the use of web application firewalls. So again, you see more and more WAF vendors or web application firewalls that have begun to be placed in between the applications, of course, that the APIs are a part of, and the services or the users who are making those API requests. So more and more vendors are churning out more and more web application firewalls and placing them as a way of protecting the APIs from attackers. In fact, even the vendors have even gone a step ahead. I mean, one of the things that they have done is to try to coin another new word for the web application firewall. So they have now added on top of what you have on the web application firewall, the API security feature. So what they now call the WAAP, the Web Application and API Protection Service. So it's now a combination of what you have in your web application firewall and API security. Now you see all of these things, web application firewall, your API gateway, your web application and API security, and what have you, are all different strategies that you have put in place for protecting your APIs. But the truth is that all of this are still traditional in the approach for protecting APIs. Now, I'll give you a couple of reasons why we call them traditional approaches. Well, but the very first reason is that these WAFs, APIs, or application WAAP, are runtime solutions. In other words, what that means is that they only protect the APIs only after they have been published and when they are now made publicly accessible. The problem about protecting an API when it has been published, when it is now made publicly accessible, is that one, it is more costly to fix the vulnerabilities that come together with it, and two, you have a race against time with your hackers. So you think that you're able to catch the security vulnerabilities in time. Well, you may not be able to cache it in time because you have hackers that are able to cache it just in time. So again, that makes that approach traditional. And that's some of the limitations I'm going to be talking about. Now, another limitation that you have for your web application firewall, your API gateways, and your WAAP is in the fact that just like the former speaker spoke about, you see, hacking APIs is no longer a thing of looking at flaws with the application. It's more now of business logic. So you now have business logic based attack for API, and that's the whole idea about hacking API. In fact, it is way it's easier to hack an API than to hack a normal web application. And speaking about business logic, and I'll give an example of what we just did. I see. I come from Nigeria. Within Nigeria, in Nigeria, we have an exponential growth of fintech organizations. In fact, you even have fintech organizations just providing API as a service. And then you have other maybe e-commerce sites that are consuming that particular service to provide what they want to their customers. Uh, Today, I currently consult for a major bank in Nigeria, and one of the things that we're able to find out, I mean, during our offensive security engagement with them, uh, as a bank, they are providing API services for some travel agencies or for some travel airways. Now we were able to find out that by just changing, now typically if you want to make a request to travel, you can simply log on to the app, the travel the app, the travel agency, make a request, determine which airline you want to go with. You can determine what airline. You can even determine how much you want to pay, and you make the payment. At the point of making the payment, it calls the API for the back end fintech organization, the one I consult for, and then that payment goes through. Now, of course, there are different prices for different routes. Okay. Now we're able to realize that by first authenticating on the travel agency, which has been authenticated, I mean, because they are authenticated to the API at the back end for that particular fintech organization, because they're authenticated, the moment we're authenticated, by just changing the ID for another travel route while maintaining the same amount, we can be able to still make a payment and get approved and still get a ticket. Essentially, what that means is that in Nigeria, we have three major states. We have Lagos, we have Abuja, we have Port Harcourt. Lagos to Abuja is, of course, a little bit far, but not to that distance, while Lagos to Port Harcourt is very, very far. So that consumes a lot of money. So you will have $50, for example, to travel from Lagos to Abuja, and you have possibly $200 to travel all the way from Lagos to Port Harcourt. Now you would a typical trip that you would the moment you want to pay for the $50 trip, you will find out that by just changing the ID right there from the travel agency side, changing it and but changing the route, still paying that same $50, but changing the route to a further place, Port Harcourt, you will be able to download and still get a ticket that will make you to travel to that further route. And that's essentially what it is. As simple as that. Simply business logic based attacks. Now, you see, the funny thing about this particular offensive security engagement is that they had a web application firewall in place, and yet it was not able to protect them against this kind of business logic based attack. Then, of course, you have other issues relating to web application firewalls, and of course, your WAFs and even your API. Another major issue is the fact that the, before even a web application firewall is able to protect your API, the traffic must be routed through the WAF. Now the question now is, In the event we don't have a particular API that is routing to the world, what happens? And that gives rise to what we know today as your shadow APIs. Shadow APIs are those APIs that you really do not have that traffic for them. You really do not have that documentation for them, but they do exist. And the fact that they don't pass through the WAF, that simply means that your APIs are not being protected. And then you have other issues about zombie APIs, and I mean all lot of things that can happen. So you see, at the end of the day, the truth becomes that your WAF, your web application firewall, though very, very good in what it protects, I mean, typically it protects you against the typical OWASP top 10 web application attacks, SQL injection attacks, and just all of that. You find out that when it comes to APIs, it falls short of protecting an organization on the security for the security of those APIs. It falls short of protecting you against the business logic based attacks, like we just talked about just not too long ago. And the fact that we need to register just about all the various APIs. In fact, for the mere fact that your API is not even registered or it is not passed through that web application firewall, you will not be protected. So now, what is the solution? Because we can talk more and more about the different types of issues that are surround what the current traditional approach is. But again, we have to go to what exactly is the solution? What exactly is the right approach for API security? Well, again, it's still the same approach that we have all known about, the shift left approach. Of course, we can talk about shift left, but again, in my conversation, I always speak about not just shift left, but also shift right or shift anywhere, shift left, shift right, because it's one thing to always think about shifting left in the area of security, but you also want to think about shifting right too, because you want to put all of that into consideration. And one very first thing in the path for protection of APIs is looking at training of your developers. And I will tell you that for sure that the people, I always say this, especially when I'm having conversations with different organizations that I consult for, that there is people, process, and technology. That you can have the best of technology, you can have the best of processes, but you see the people, you cannot always determine the people. The people is the reason why security is never at 100%. Not really your technology, not really your processes, because you can ensure that technology is giving you 100% of what you have. You can ensure that you put in place the right processes, but you see the people are always and will always be the problem. And the people in this context are your developers. So again, the first and most important in the path for source code protection for API is looking at training developers, helping developers to be able to understand what the potential security vulnerabilities are. Then one of the major issues that you want to look at is at the design stage. So the design stage at the point where those APIs, before they are even coded, and that is this is the point where you want to put in place API documentation in terms of your Swagger files. Now you see, by implementing security at this point, you are able to take away those kind of zombie API, shadow APIs that they really is no known no documentation about them that no one knows about. But because for every single API that is coded or that is developed, you have a specific API documentation for them that helps to be able to enforce protection at the moment when we go to the deployment stage. Then of course, away from the design, the coding is not the most important. The moment when the code is actually being developed. So rather than focusing on the web application firewalls that protect the APIs at the point of where they are published, how about implementing security solutions that integrate directly to the development environment of the developers? So that at every point, just the same way they are checking for functional issues at the point of developing, the same way they are checking for functional errors, the same way that security solution is also checking for security issues at the point of development. So it's integrated right there at the development stage. All right. So it's able to identify what the issues are. Is it an authorization issue? Is it an authentication issue? Is it what kind of issue that is able to identify? It's able to identify it, and the cost for fixing those vulnerabilities is lesser because you're able to identify those vulnerabilities at that stage. You also want to look at implementing at the check-in stage. So a developer has finished developing, of course, using a DevOps environment. There is a point where he checks in his code into the pipeline. At the point of checking too, you want to be able to identify, you want to be able to ensure that that solution, security solution, is able to identify issues at the point of checking stage. You see, uh, when you being able to identify security solutions or even those APIs helps to be able to mitigate against the issue of not knowing all of the APIs that we have in our environment. What another term we call zombie API. So we don't know what APIs exist because it's possible that at some point developers can continue developing. They may upgrade a new API and they may forget about even removing the other one. Because we have put in place check-in controls that are able to determine what APIs are currently existing vis-a-vis the ones that are going to be upgraded or the ones that are going to be updated. We are able to determine that okay, currently we have so and so zombie APIs that are existing in our database that need to be taken out. Then, of course, you have the deployment phase, and that's the part where you want to look at not just the coding part of it, but also the operations, infrastructural issues, configurations, especially with regards to integrations to existing infrastructure, whether it's on-prem or in the cloud. So, what's the point? The whole idea we're simply saying is we must be able to look at security protection at the source code level. Looking at security protection at the source code level helps to do two things. One, it helps to reduce the time taken to fix the vulnerabilities. It helps to be able to reduce costs, but most importantly, it helps to actually protect you against API-based attacks, actually the business logic attacks. Then again, I spoke about the fact that apart from just the shift left approach, you also want to think about shifting right. All right. So apart from after deployment, we would not just want to leave it like that. We want to continue doing continual testing to be able to identify that all that we have put in place is actually as it is. Okay. So the shift left, shift right approach combined together helps to be able to ensure that we are putting in place API protection at that source code level. And this is the most secure and cost-effective way of protecting source code. In my interactions with different fintechs here in Nigeria, we have been able to, of course, after engaging with them, identifying why their WAFs are not enough, why their web application firewalls are not enough, by putting in place a proper security model for protecting their APIs at source code level. A number of issues with regard to vulnerabilities with APIs have reduced drastically. And that's something that other organizations would want to adopt or want to develop. All right, that's all from me.
Thank you, Goodness. We do have a couple of questions and we've got a few minutes to take questions. So we had a question around, usually AppSec is completely disconnected from the development team. So do you have recommendations or, how do you go about kind of merging AppSec into the software development lifecycle?
Yeah, so that's a very simple, that's a very important question. There is this terminology called the DevOps technology, DevOps terminology, and as we now have what is now called the DevSecOps. Essentially, what that simply means is that we are taking security and putting it as part of our DevOps routine. So my routine as a developer today will be open my system, pick up my development environment, and start coding right away. Now, I don't want, and this again points to what security consultants or security guys in security always do, to try to come at a later stage to come and say, oh, you want to push your application to production. No, 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 come, I need to test your application. That stalls production. That stores deployment to production. So I as a developer, because I want to be able to harmonize the way I work with the way security works. I want to be able to say, okay, the security team should always come at the point when I'm developing. Integrate whatever you have to do. So that at the moment when I'm developing, I'm identifying functional errors. I should also be identifying security issues. So at the moment when I am deploying, I am not just deploying a functional application, I'm also deploying a well secured application because I am able to integrate it right at the point of where I was developing.
Yeah. And I think, something that you mentioned all the way at the front of your talk around, around documentation and where APIs are housed and how they're managed becomes a critical part of that, right? Because I think that there's that kind of governance piece that needs to be throughout the software development lifecycle that says, not even just from a testing perspective, but if the API is well documented and you know where they're housed and where they're managed, then it becomes much easier to do all of the right things during that development lifecycle, right? And you don't end up with those shadow API issues that some of us are still struggling with. That was a great talk. Goodness, thank you. I really appreciate it. If there are any other questions that anybody has, we're a little bit out of time for questions in this session, but feel free to still put them in the chat and we'll get them over to Goodness and we'll get them answered and send them to you. Thank you, Goodness, for joining us today. Appreciate it. That was a great